Hello students, now let us solve some more examples on fundamental principle of counting. So the example, how many 7-letter words, 7-letter words can be formed using the letters A, B, C, D and E. If the first condition is that the word must contain exactly one D. Word has exactly one D. And the second, the word must contain at least one D. At least one D. Now here we have to form 7-letter words. So 7 letters are there. Suppose 7 letters. These we have to fill up. This is our word. This forms our word. Using these letters A, B, C, D and E. So how many letters are there? 5 letters. Now what is the first condition? The first condition is that the word must contain exactly one D. Now D can be placed here, this D can be placed here, but D won't be repeated. It should be once only. That is the condition. So here it has exactly one D. So if I will place D here, as an example, I will place a D here, other student can place here, other one can place here, as such. So D has how many choices? 7 choices. But for other places, how many choices are left? So A, B, C and E. Now there is no any condition for these letters. So these letters may be repeats. So here this how many letters are left? 4 letters are left. So here how many choices? 4 choices. Again this all the remaining 6 places has how many choices? 4 choices. So here what should I write? First we fix the position of D. And for this we have 7 choices. 7 choices. And in each of the remaining places, we can put any one of the remaining letters, any one of the remaining 4 letters, Therefore, any one of the remaining 4 letters, and that has how many choices? For this or for that, 4 choices. 4 choices for each place. How many choices? 4 choices for each place. Fine. Now therefore total number of words of this kind, total number of words are how many? 7. This is for D only, and the remaining 6 places are there, and for each place there are how many places? 4 choices. So it will be 4 raised to 6. Now the second one, the word must contain at least one D. Minimum one D will be there. So maximum everywhere it may be D. It is a choice. So how does this will be solvable? Now here let us use our third rule. What does that say? The total letters, total number of letters formed using these all 5 letters. So total words formed using these 5 letters, and the words doesn't have the letter D. Means what? The total minus unfavorable. Total minus what? Unfavorable. That gives us the favorable. Favorable means what I want to say here. If I have got the total letters from this, using these 5 letters we will form, and unfavorable means what? It doesn't consist D. Then obviously the remaining are left, that are what? At least 1 D is there. At most 7 D's are there. These one are left. So here what should be the answer? We should write first we find the total number of 7 letter words. 7 letter words. Now for 7 letter words, for each place we have how many choices? 5 choices. We have 5 choices. Therefore number of such words. Why does we have 5 choices? As 5 letters are given to us. That's why there are how many choices? 5 choices. Now therefore the number of such words. Number of such words are how many? 5 raised to 7. Fine. Now we find place. Now we find place. And now we find the words of length 7. Now we find words of length 7. That do not contain D. Therefore if it do not contain D, so for each place, if the words do not contain D, then for each place we have how many choices? We have only 4 choices. As only 4 letters are left there, it do not contain D means what? Only A, B, C and E will be there. So we have only 4 choice for each place. Therefore number of such words are how many? 4 raised to 7. 7 places, and for each place we have 4 choices. Therefore number of such words equal to what? 4 raised to 7. Now therefore as I say earlier, the number of words of length 7 that consist or that contain at least 1 D is what? That are how many? Total numbers minus this unfavorable that do not contain D. So that are what? 4 raised to 7. This is our answer for this second part. Fine. Now let us go for the next example. Now the next example is that how many license plates? Other example is that how many license license plates can be made using either two letters followed by 4 digits, or 2 digits followed by 4 letters. Now here we have to prepare license plates. How many we can prepare of this kind? Which kind? Those 2 letters followed by 4 digit, or 2 digit followed by 4 letter. Means some of the license plates are these kind. Here they consist letters, suppose A, B, and here what the numbers 1, 2, 3, 4, and other one is of which kind? Now first of all they have numbers 1, 2, 3, and finally it has what? Or the 2 digits, 2 digits. How many letters? 4 letters. This is the other type. So this is what the type 1 for license plate here, and this is type 2 for license plate. 2 digit followed by 4 letters and 2 letters followed by 4 digits. Now as you know, for letters we have how many choices? 26 choices. So the letter place will be filled up by 26 ways, and the digit have how many choices? 10 choices, 0 to 9. Therefore the digit place will be filled up by 10 ways. Fine. So solution can be written as, first we count the number of license plates of each type. Suppose let me go for type 1. What is type 1? 2 letters followed by what? 4 digits. 2 letters followed by 4 digits. So here total how many? 6 places, as I say. So 2 letters, so these 2 places have how many choices? 26 choices, and further each place will have 10 choices. So total number of these license plates are what? This product. Therefore the number of license plates of type 1 are how many? 26 square 10 raised to power 4. Now let us go for type 2. What is for type 2? In type 2, 2 digits followed by what? 4 letters. 2 digits followed by 4 letters. This is the kind. Now 2 digits. So 2 digits means these 2 places will have 10 choices. Fine. And the remaining one are the 4 letters. So each one should have 26 choices. Therefore the number of license plates of type 2 are how many? 10 square into 26 raised to 4. This is the number here. Fine. Now what they say, how many can be made either of first type or of second type. Now the sense of or is here. As the sense of or is here, so we should use the addition rule. Therefore using addition rule, using addition rule, what we get? The number of license plates are, number of license plates of, or number of license plates either of type 1 or type 2 that are equal to what? 26 square into 10 raised to power 4 plus 10 square into 26 to the power 4. 26 to the power 4. This is our answer here. Fine. Now you can do this sum on calculator if required. If you keep this one as it is, it also gets a full credit. Now the next example is that, let me take the next example. How many non-empty different collections, can be formed from 5 apples and 8 oranges. Now here obviously the apples and oranges are what? Identical in shape. So how many non-empty different collections can be formed? So we have to collect the apple and we have to collect the oranges. Among these 5 apple and 8 oranges. So first of all we should give the numbers to these apples and the oranges. It is just like an example as I have taken in the example that 2 boxes are given to us and we have to draw an object from that. Same kind of example is this. So here 5 apples and 8 oranges. So we should numbering them first. Suppose the apples, for the numbering the apples, we will denote or we will number it as using the letter X, and here the oranges will be numbering using the letter Y, suppose. Now the X varies from 0 to 5. And there may possible we are unable to draw an apple there. That is also one collection, and numbering for oranges is from 0 to 8. So let me write first. A collection is determined if we have or we know the number of apples and number of oranges in the collection. How many we have to select? That is we are unaware about that. Fine. Now let the number of apples in collection or in the collection be X, and number of oranges in the collection be Y. Therefore X varies from 0 to what? 5. So number of choices are how many here? Number of choices equal to what? 6. 0 to 5, so number of choices 6. And y varies from 0 to what? 8. So how many number of choices are there? 9. Therefore, number of choices are how many? 9. Therefore, total number of collections. Now we have to collect apple as well as the orange. So sense of and is here. So we have to take a product. So 6 into 9. So that total number of collections are how many? 54. But the collection corresponding to x equal to 0 and y equal to 0. This is one of the value for them, x and y. So collection corresponding to x and y both are 0 is what? Is an empty collection. This is only one which is what? The empty collection. Now what is the question? We have to collect the non-empty collections. Therefore, the total number of non-empty collections are. Therefore, total number of non-empty collections. Total number of non-empty collections are how many? 54 minus. This is what? Only 1. So minus 1. So how many? 53. This is our answer here. Now let me take one more small example. Then we will stop for this video. Later on we will continue again. Now next example, that if cardinality of A is 5 and cardinality of B is what? 7. Then the question is that how many functions are there from set A to set B. Then the second question is that how many 1-1 functions are there from set A to set B. So the solution is that for the first, each element of A can be mapped to any of the 7 elements. Means each element of A has how many choices? 7 choices. And A has how many elements? 5 elements. So each have 7 choices. So these are 5 elements. Each has 7 choices. It can be mapped to 7 elements. Therefore, total number of functions from set A to set B are what? 7 raised to 5. 7 elements of B. Therefore, total number of functions from set A to set B equal to what? 7 raised to 5. Now the second one is that how many 1-1 functions are there. Now you know 1-1 function means what? If the elements are different, then images should be different. Or another definition is what? If images are equal, then the elements should be what? Equal. This gives x equal to what? Y. These are two different definitions for this. Now, if we use this definition, what if two different elements should have different images? Means two different elements of A should map to different elements in say B. So, first of all, for that, the mapping of first element we have, for the mapping of first element from set A, we have 7 choices. So, for second element, we should have 6 choices. These are them. Look at here. Now, the first element should have 7 choices. The second element should have 6 choices, as it should be different. It's fine. The next element should have 5 choices. Then the next one have 4 choices, and the next one have 3 choices. Therefore, to get 1-1 mapping, the mapping of first element have 7 choices. Fine. Excluding the image of this element. Now, excluding the image of first element, we have 6 choices. We have 6 choices for mapping of second element of A, and so on. Therefore, total number of 1-1 functions are total number of 1-1 functions are how many? 7 into 6 into 5 into 4 into 3, that are 2520. Okay, this is our answer here. So, total functions are 7 raised to 5, but 1-1 are how many? 2520 only. So, now here we will stop for this. Next video we will take some more examples and the inclusion exclusion principle. Thank you.